Similarly, after we build a relational database, we should be able to access the data. You know the answer, how to access the data, using structured query language. But structured query language is, as you know, when you learn the language, the program language, which program language did you learn the first time? C or Java or some Scratch language? But actually, does computer understand the C language? No, actually not. The computer understands only assembly language, machine code, machine language. Eventually, it is converted. Okay? So, like that, SQL is for relational database or for human being? It's for relational database actually does not know the SQL. It's for user, human-friendly language. Especially it's very, very high level. High level means what? I mentioned that high level, low level every time. It's a human. Okay? Low level means machine. It's close to machine or the human? It's a human being. So it's very easy. So SQL is one of very intuitive language. You can understand. Even though you do not know the relational model, you understand. However, we are not going to use just the SQL. We should be able to understand what's going on behind. Because of that, we'd like to know. Just like as if you are learning the assembly language. Okay? After you learn the first or second language of the computer programming, you'd better know how it works, like the assembly language. Similarly, so before we start the basic SQL, advanced SQL, some of them already used. Okay. However, in this class, we are going to start to discuss about what is behind, what is the data structure of that SQL program language, that is the relational algebra and relational calculus. Before we start, what is a calculus? Did you take the calculus class? Equation? It's from algebra. It is true. You learn the pre-algebra, algebra, pre-calculus, and calculus. It's kind of such as that. So there are different ways to define how to access the data. First time when Dr. E.F. Code designed the relational model, so he used the definition of a relation. He used the several constraints. Then to develop the way to access such a relational model, he borrowed the idea of first relational algebra and actually relational calculus. Relational calculus is the kind of define the condition what you want. Okay, what you want. I need something. I need employees who earn the 10,000 a year salary and the female and works on the department number 1. Such a condition only. Then return the data. So it is kind of a condition of your data, but it doesn't show how to access the data. Okay. So to address that one, the relational algebra is borrowing the idea of an equation. Okay. Equation consists of what? Number, variable, and operation. So operation, plus, minus, multiplication, division. So based on that, we are going to have a number of factors. So if you manipulate such a factor, it's called a factoring that you know. X minus 1 squared is x squared minus 2x, whatever, right? A plus b, the cubic is a cubic plus the 3ab squared plus the 3a squared b plus b. I still remember. So this kind of thing, we borrow the idea of such an algebra to show how to access the data. In other words, how to operate, okay, manipulate such a data. That is a relational algebra. So we are going to see a number of operations, like the plus, minus, multiplication. So we are going to see such a operation. By combining operation, it will be relational algebra expression. That relational algebra expression will be the basic of SQL. Then the understanding SQL is not difficult if you understand the relational algebra. Okay, so first, we are going to see the number of operations from now on. Then, from time to time, I will introduce the characteristics of such a relational algebra. So first, before we start, we are going to use the same database that we have seen before, like this one. So keep in mind, I believe in your mind you already have the kind of the snapshot of this relational schema diagram. So I'm not going to show every time for this. So instead, if you are not sure, that you can use the handout or the separate page. So using this database, we will see such a relational operation. Okay, so first, before we start, what is a relation? What is a table? It's like this. For example, employee as the SSN primary key attribute. And the real data 111, B, and so on, 112, and so on. This is the relation, this is a table. A group of data or a group of attributes. So we are interested to access data this way. Later we will see this way also. Right? That makes sense because the relation table is consisting of a number of data, number of tuples. So we are interested to access such a data. To do that, we need first operation that is called what is this? It's Greek letter, either one that you like. It's a sigma. Okay, small letter of sigma. It's a selection operation. Selection means we write select the data this way. I wanna select the data whose salary is higher than 5,000, for example. 5,000 is the condition, higher than 5,000. I'd like to retrieve all the data whose salary is bigger than 50K. At this time, if you have condition and retrieve a number of tuples, number of data, at that time we can use the selection operation. How can we use? We use such a relational operation. This is called the relational operation. Two parts. One is input, and this is as a subscript. This is the condition. Two parts. For example, input is the relation name. In this case, for example, employee. How many? One. Okay, one input. From employee, I wanna retrieve salary is bigger than 50,000. You can put the condition as a subscript and parentheses. Very simple. This is a selection. Okay. Then, what is the output of this one? It will return, like the output of that operation will be social security number, blah 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 blah, and salary 111, 112. Whose salary is like 81K, 100K will be returned. This is the output. All the data will be returned. Looks like what? Another table, another relation. So that's one characteristic. Any relational operation, input is relation. Output is also relation. Right? One more time. Because we are going to use the relation as an input of operation. The output of operation is also it's a relation, part of a relation, but still relation. But one definition of a relation is group of data. This is a group of data. So this is a relation. That means, one more thing. We can use output of this one, this relational operation, as the input of another operation, which means like I have another selection operation. Okay? Then ENO is equal to 1. Then input is is it possible?
Yes.
Yes, because this one is the relation. Then can be input of the operation. Okay? Then we can apply the selection condition like this. This is the same as what? ENO equal to 1 and salary like this. Okay? So this is the characteristic of the relational operation, which means we can extend any logical operation and or not. We can use such a logical operation. Also, commutative, associative rule can be applied, or distributive rule will be applied for selection operation. Okay. One more thing. This is the one relational operation. So this is called the relational algebra. This is called also relational algebra. However, if you are using two or more operations at the same time, okay, like this one. How many operations? One operation. How many operations? Two operations. This is called relational algebra expression. So this is a one operation. By combining several operations, it will be relational algebra expression. Like when you write the essay, so any language start from the number of vocabulary word. By combining number of words, it will be one sentence. A number of sentence will be paragraph. Then number of paragraph will be one essay. Similarly, by combining number of the operation, it will be relational expression. Later, this expression will be converted to the high-level language. That is the SQL language, structured query language. 90% same, which means if you understand the relational algebra expression, then it's very straightforward to understand the SQL later. Okay, so this is the relational algebra. So what we are interested in this class is whether we can make the relational algebra expression or not. Okay, but sometimes I'm using the relational algebra instead of a relational algebra expression. Okay, it's too long to say. Okay, you can understand even though I'm using the short word now. One more thing. So I mentioned the several characteristics already. One more thing. This is the Professor Lee said something the relation of, but there's no name. So we are going to make the name of the output. Output, this one. The name for the relation that is arrow like this. And this is the EMP, whatever the name, like the output. EMP out, you can name. Or temp. Sometimes we can use the TEMP, P, whatever name we can name it. So one more thing, this is a rename of what? Relation. Benefit, we can use TEMP on the bar, EMP. Like that. No difference. We can use the rename to rename the output of this one. Then this is a final out. We can rename. Then this is a, or sometimes we use the result for the last result. So this is a rename. Any questions? Very simple. So that is the reason relational model is popular and easy to understand. So this is a relational algebra operation. First, relational algebra the operation. Go back to this. This is one way. There is another way to access the data. I know. Another way to define the relation. Relation is group of attributes. Right? You remember that? Group of attributes is also table relation, which means we are interested to access the data not this way, this way. I need only social security number and salary. Okay? Then go back to here. We are going to define, use what is this? Pi. Pi. Capital letter of pi. Pi usually used for what? Capital letter pi used for what?
To select specific value.
Sum is kind of opposite of sum. Multiplication. But this is just used in relational algebra expression. Okay, don't be confused. Then pi means it's a projection. Projection means I wanna retrieve, I wanna access the data in this way. I need the social security number and salary. Similarly, we can use in this way. Okay? Then input is just like this one. This is an input. What is that? Relation. Then this one is the list of attributes that you wanna access. Like for example, in this case, SSN, comma, the salary. So for example, employee. Okay? Then output will be, in this case, SSN, salary, like this. Output of this one. If I want to make the rename, you can rename using this one. It's the output. This is a projection. Then, you may have the idea. This is a temp. We can combine this one. So I want to access an employee whose salary is, I want to retrieve salary and social security number whose salary is bigger than 50K. We can combine selection and projection. Okay? Why? We can make always the relational algebra expression. For example, in this case, if we replace this one by TEMP, that's it. That's the output will be SSN, salary 111, BP 1K, and 112 is 100K. This will be expected the output. What is this? This is a relation. Relation of what? The rename out. So this is out one. Usually we like to put the last, the relation as a result. For example, this is a result. Okay. Any question? It's very simple. So we can combine. We can always make the relational algebra expression. So yes.
If we select if you make a selection of just one column, you might select this from this table. Isn't that a projection as well?
So you wanna select only the single column. Yes, you can use the projection. Like for example, what you want is, for example,
So
salary.
it's partially a selection, kind of selection.
Selection is the, so don't be confused with the selected. Name is just a selection. Selection means in this relational algebra, this way. Okay, data by data selection. But when I say that's the reason I usually say I want to retrieve the data. Instead, I want to select because you confused. You are confused so sometimes. So I want to retrieve the data by this. But anyway, she raised a very interesting question for this. So, for example, here, I want to retrieve the salary. Whose salary is more than 50K? For example, 111 is the 50K. 112 is the 100K. 113 is the 50K. What is the, obviously it will be this one if you have the social security number. But if you take out the social security number, is it correct or not? Yes? No?
Yes.
Yes.
Anyone? No? Extra point. If you answer the reasons why it's not correct.
In the selection, we are doing salary greater than 50,000.
Oh, my mistake. 81. 81.
That would be right.
Right. Anyone? No one? What is the definition of a relation? Group of data. Then, what is the constraint that we discussed? Key, which means unique. Is it unique?
No.
Which means it's not the relation. So, in any relational operation or expression, return the data, but that return data should be unique. Automatically remove the duplicate data. Why? Because output is a relation. Relation should be unique. It has the primary key, at least one, not at least it should have the primary key. This time it will be primary. To make it primary key, we eliminate any duplicate data. That is the main difference between relational algebra expression versus SQL layer. Structured query language SQL does not care duplicate or not. Just return as it is. However, relational algebra operation return only duplicate data and only unique data, removing the duplicate data. The reason is that the SQL first time was implemented based on this definition, which means whenever you just select the data using the SQL, okay, it will return only unique data, removing all duplicate data. Then user complain, I want to take care of such a duplication by myself in my program side. So that makes sense sometimes, okay? So, and also, it takes a long time. How do you find the duplicate data, redundant data? If I ask the programming to find the redundant data, duplicate data, how can you find? You need to store. That is one word. Intersection. Sorting. You need to sort the data. No other way. So it's a sorting, it's a fast algorithm or expensive algorithm. It's a very, very expensive algorithm. What kind of sorting algorithm you learn? Quick sort, bubble sort, something sort. So each and every application, even the Google used a lot. When Google has an interview, they ask to implement. I give the one temporary space, 1 byte temporary space, and we'll give the 100 data, then implement the sorting algorithm. That is faster than whatever. Really, that was a very popular the coding, the question before on-site. So sorting is very, very expensive. So whenever the database returns the unique data, they need to sort. It doesn't matter when you have 10. It doesn't matter when you have 100. But it should be problem when you have millions of data. 10 millions of data. Okay? It's a huge overhead. One of the database system used as a default uniqueness is the SQL Server. SQL Server use automatically as a default, like the distinct. If you use the SQL Server, Microsoft SQL Server, before it default query is select distinct, the from table, whatever. This means automatically sort the data. Okay. When you have the less data, it is okay, but it will be problem. So this is the main difference. So output of any relational operation should be unique. So this is the projection. Then I'd like to F name, middle name initial, and the last name. Any developer in computer science or the IT developer, it's as far as I know, most of them are very lazy, which means they don't want to write down make the long name of a variable. Instead, try to make it shorten and shorten. So for example, the first name and last name. So instead, FN, LN. Instead of name, NN. Make it abbreviation or shorten name, right? So how can we make such a name? Otherwise, we need to use the old name of the attribute. So to address that problem, there is another relational operation, that is the rename of the attribute. It's a code. Okay. So we use a lot of Greek letter. So we are going to use the row. Row is like this one. So I want to rename is the F name L name. Input is this. Okay? Or you can rename it, then row, then FN, L, then output. So output is like this. Attribute name is changed as FN, LN, okay, then J, K, and Li, like this. This is the rename of So we can make the relational algebra expression by combination of this basic operation. These are the really basic operation. Okay, as you can see, there are two different ways to represent any request using the relational algebra. One is list of relational algebra expression. Another way is you can make the one relational algebra expression. Either way is fine. Output is the same. So as long as output is the same, either way is fine. Okay? However, later you will see the database query optimizer is one of the kind of the brain of the DBMS. So when you access the data, think of it, I used this one, this example a lot. So when you travel to the Manhattan, I have an interview in one of the company in Manhattan, so I'd like to travel. So how many different ways to go to the Manhattan 42nd Street, 42nd Street? From Bridgeport. 2 or 3. You can take the MTA train, or you can drive. You can bicycle. You can walk. You can use jet, the plane, private jet, or you can take the ferry, go to the Port Jefferson, and go to the train, then go to there, rent a car. Many different ways. Probably thousands, millions of them you can imagine. Then how many of them will be selected? Only one. what? Fastest one. When you access the data, relational database, there are a bunch of different ways you already realize. So when we access the data, combination of what? Relational operation. So there is one smart module to decide which way is the fastest way. Okay? So, for example, in the morning, so there might be traffic, so it's not a good idea to take a drive instead of the MTA. So for the MTA, the time, so then you can select the fastest route, fastest way to go to the Manhattan. Similarly, Query Optimizer decide the fastest route to access the data using what? By combining relational operation. So it is good idea to understand such a relational algebra expression with number of relational algebra operation. Later, we will see the detail, the query optimizer, how it works. That is a query optimizer. And that is called query processing, most important part of the database engine. Okay, so these are the basic operation. Any question? We will see more example. Yes?
Suppose I am projecting 3 attributes, but I want to rename only the second attribute. How can I do it?
So you want to access only the second one?
Rename only the second attribute.
You want to rename. Then you can, for example, if you want to rename this, you can first name, let's say this. Then rename. Later in SQL, the structured query like high-level language, you can only rename the what you want. That is called alias. So alias is kind of a nickname. You can nickname, you can aliasing only specific attribute in SQL. Okay? But here you can use such a way. Okay, so to little bit speed up, I'm going to use the so we already see the select. So we can select, use the select in this. Okay. So all the such the property that you learned in your the middle school or the elementary school, right? So it can be applied. So you can use any commutative or the cascade and so on. So for example, what's the meaning of that? From this. So I try to retrieve the employee. Okay? Who works for department number 4 and salary is higher than 25K. Or from the department number 5 and salary is higher than 30. So I want this one. You can make. Okay? And the output will be like this one. All tuple will be returned. Okay, so then the project, I want to specify the list of attributes using the list of attributes, like this one.